Okay, in example 2, we're estimating and predicting from an exponential growth model. We're going to use the data in table 1 to model the population of the world in the second half of the 20th century. We're going to use the model to estimate the population in 1993 and to predict the population in the year 2015. So what we're going to do in this scenario is that we're going to let t equal 0 in the year 1950. So we're going to use that as our initial value. So we have 1950 and then the output is 2,560. So we're going to let 0 represent that year, and then the initial value problem is dp over dt, which is equal to k times p. And then we have p of 0, which is equal to 2,560 millions. So the solution ends up being the following. So we have that formula, P of t, which is equal to the initial population, e to the constant k times the time t. So we're going to estimate k by using the population in 1960. And so if we take a look over here, we have 1960 for the year, 3,040 population in millions is the output. So how many years have passed since 1950 and 1960? Well, that's 10. So we know that t is going to equal 10, and the output's 3,040. So now we have this equation, and now we need to solve for k. So the logarithmic equation gives us 2,560 e to the 10k, which is equal to 3,040. We divide both sides by 2,560. In order to get the exponent, we would take the natural log of both sides. So we end up with 10k, which is equal to the natural log of 3,040 divided by 2,560, and therefore k is going to equal 1/10 times the natural log of 3,040 divided by 2,560, which gives us approximately 0.017185. So if we convert that to a percent, the relative growth rate is about 1.7% per year, and the model is going to be the following. It would be P of t, which is equal to 2,560 e to the power of 0.017185 t. Now we estimate the world population in 1993. So how many years have gone by since 1950? Well, we're going to take 1993, subtract 1950 to get 43. And so P of 43 is going to equal 2,560 e to the power of 0.017185 times 43, which is approximately 5,360 million. Now, the model predicts that the population in 2015 will be the following. So 2015 minus 1950, and this should be P of 65, because that means that 65 years have passed. So we're going to plug in t to be 65 and then evaluate this function, and we get approximately 7,822 million. And now the graph in figure 3 shows that the model is fairly accurate to the turn of the century. So the estimate for 1993 is quite reliable, but the prediction for 2015 is much riskier.